Thank you everyone for your patience. Our session has now started. Manesh, please take the stage.
Hi, Aris. Thank you very much. I hope everyone can listen to me. I'm Manish Harsh. I'm a developer relations for autonomous driving, and we have put together a great team of experts here for all of you. Just a quick overview on for next 1 hour. Well, all these folks will be helping you to address all your questions and queries. So in the common room, it will be me. Pradeep will be joining soon, Bill and Jared for specific topics. These will be open forum questions. You can throw to 4 of us and we will handle it and guide you to the right direction. In the breakout rooms, we meet Matt Cragen, Siddha Ganju, Anant, Mikhail Yurusov, Luke Harvey, and Venkatesh Rao. And we have mentioned their expertise, although they can handle any questions, but to be specific, we have put together a skill in front of their names and their email IDs as well to follow up on these specific areas. So moving from there, let me set the context aligned to stay focused on autonomous driving and enterprise automotive areas. Aris, can you go to slide 2 for me? Yeah, what to expect, just to get the ball rolling. You can get a broad view on the GPU stack, GPU platform, end-to-end drive infra, which would include training and simulation both, and a lot of other features we have bundled in for you. Acceleration tools and resources. We have 200 plus SDKs offered by Nvidia, built on top of our CUDA-X platform. The accelerated applications. So you can ask those questions based on your interest areas, and also ask where to start from. How do you really go for it? Yeah, third slide, please.
Hey Manish, you can also click on the slide.
I can also do it. I'm so sorry, I'm learning the tool as well. Yes.
No problem.
So these are the questions we have been, in our regular sessions with our customers, partners. You would like to know the developer tools and resources. You would want to know the data center apps and acceleration tools. What type of software stack do we offer? In the AI infrastructure and simulation, we are very happy to guide you on the best practices. We have been doing this for many years now, and we've learned it in a hard way. And we have our own autonomous vehicles running on the road, so we know the entire end-to-end pipeline and the challenges we face as an overall industry. So best practice is a very good start point. It may not be covered in 5-minute session, of course, but feel free to reach out to your expert, and we'll be happy to have more detailed sessions as a follow-up. Deploy and manage workloads on GPU servers is once you get into a bigger clusters for training and simulation, you would definitely want to have some learning from our side. How to run jobs and orchestration. You have Anant over there to address those questions. Techniques for capacity planning and monitoring tools, AV simulation and validation with Drive Constellation. If you have not heard about Drive Constellation, Matt Cragen and Venkatesh, good picks to help you understand that. Parallel programming fundamentals always comes in handy. DL at scale for CUDA, using CUDA, and deep learning models and tools, workflows. So going from here, I just wanted to set the question. This is the overall area. We want to feel free to pose questions to us. You may have followed the guidelines by Iris, how to ask questions to us. And Jared, anything to add from here? Before I move into the next slide. Jared Peart is co-chair with me.
Yeah, no, I don't have anything to add. Just the only thing is just if you want to sign up, I think on the chat you got the one-on-one signups, and we're here to help. So any question out there is not a bad question. So please feel free to ask away.
Sure. So I'll take a little twist to it. I'll jump to the slide 10, which is very focused to the areas we would want to have support you the most. So training platform and stack is where the labeling, training, and we have built a intense platform here. And we have understood the workflows, we have understood the areas where the acceleration is required. And so we need the scale. I mean, doing a training is easy, but doing it at scale is a challenging piece of the puzzle. So that's where we want to focus. So pillars of AV development would be DNA training, train the network for AV perception. We would want to, if you have questions on the DGX or equivalent compute infra, we're happy to field that. And there are a lot of techniques and software to scale. There are plenty, but these are the ones which we see in the industry and most of the developers would benefit. And the mixed precision with AI frameworks, deep learning primitives, deep learning inference engine, TensorRT. We have Mikhail, who will be happy to help you with TensorRT, is an expert in that. Deep learning for video analytics, and optical flow for video inference. And we have a SDK for tuning domain-specific DNNs as well. So transfer learning toolkit will guide you on how to start with them. Simulation and validation is our platform, Constellation platform, where you have a drive sim, drive constellation simulator, and drive constellation vehicle. It's a set of two boxes on the left. You see a small image. I couldn't get a better one, but this is to give you a brief idea of what it is. And the integration with the ecosystem, the environment models, sensors, vehicles, and traffic and scenario models. And because it's a little complex it's not, we really want you to have one-on-one conversation with us, how to ramp you up. Venkatesh Rao is here for you to guide you those questions. Jared, again, just to keep the conversation going, this is where we want to focus for this team, for this group. Anything for you to add?
No, I don't. I don't
Okay.
have. I think you brought it up. Like I said, just if don't be shy about asking questions.
Yeah.
And Jared and Manish, we saw a lot of great questions flow in onto the Q&A tab.
Yeah.
So Jared, why don't you pick a questions for Manish to answer?
Okay, I'm gonna look right now. Hold on.
So while Jared is picking up a question, let me take you to the fundamentals. I'm doing it completely upside down, but I think it's important for all of us to understand the fundamentals of GPUs and why we are conveying this message again and again for the end-to-end. For the success of AV industry, the full stack optimization is the key to performance, not one hardware or the software. And that's where the value proposition of NVIDIA's GPUs is. We give you the complete stack and you build on top of it. It's an open platform. And we want to make sure that you're successful and understand the nitty-gritties of it and build your applications on top of it. We have understood your workloads more or less and want to learn more. What are your performance needs and get the optimization needs. If we have not addressed your specific corner cases, we would be happy to work with you. There are multiple choices for programming on GPU. There's not one way to skin this cat. And trust us, we have been many years. We are learning it from every industry, from graphics from gaming to healthcare to oil and gas. We are working across the industries, and we are realizing every community has a different way of solving. And the needs are different. The performance needs are different. The throughput, latency needs are different. So you pick your battles. We will help you succeed. Universal hardware with software stack is key to GPU computing. I believe everyone understands it. Just wanted to emphasize it again. These are fundamentals. Keep in mind, and we are happy to work with you. Now, is there any questions while I'm talking here?
Yeah. Can you hear me?
Yes.
Manish, okay, we have a question here. Can you talk about how much data is needed to train a neural network, and how long that training takes? I've heard that there are greater than 20 neural networks needed, and each needs greater than a terabyte to train, and training takes a few days for each neural network.
Inviting Pradeep to answer this, to answer the specifics. Who's the question? Who is asking this question? Can we get it? Can you point me to that?
Yeah, the question was asked by Jordan Janesco.
Jordan, okay. Pradeep, you in the room? Can you pick this one while I keep moving here?
Hey, Manish, I believe Pradeep will be joining us in just a few seconds.
Okay. Yeah, so we'll field it. Let's keep moving. We'll get the question for Jordan. So, we want to share the way we see this industry growing. So, and we see 4 pillars here. End-to-end workflow for AV infrastructure is a very important piece of the puzzle. You may have heard, some of you may have heard of MagLab project we have internally and being coming to life very soon, accelerating each and every aspect of the workflow. So develop AV DNNs and model training. As autonomous vehicle may require as many as 48 DNNs working in parallel, being trained and deployed in parallel to really make a functioning car. And the scale, what we are talking here requires a really sophisticated infrastructure from compute and storage perspective. So we look at it very keenly. These boxes may look simple, but there's a lot of science behind each of them. So we have built reference architectures and the knowledge which AV infrastructure would require. Testing and validation, very important piece of the puzzle. Constellation is all about that. I'm sure you are in queue for if that's your interest area. Matt, Craig, and Venkatesh are there in the rooms helping you. And AI/ML applications, which is across the industry, but we want to, a lot of autonomous vehicle applications are very important, and and we have understood what level of training is required in them and what infrastructure would be needed in order to deliver. These 4 pillars, we have dedicated teams for each of them, and we optimize them to your needs.
Okay, so
yeah, who's that?
Yeah, this is Pradeep, and can you hear me now?
Yeah, we can hear you now, Pradeep.
Okay, thank you. Sorry, somehow some issue with my mic. So let me try to respond to the question asked by Jordan. So his question, just to repeat for everyone's benefit, is how much data is needed to train a neural network and how long that training takes. Okay, so the training of the neural networks, specifically I'm talking in the context of the autonomous driving, where you have networks like object detection, you have networks like free space segmentation, the lane marking detections. Each and every network requires a different amount of the data. We have a different experiences, but to reach to the level of accuracy which somebody will expect to deploy in autonomous vehicles, one of the most complex network here is the what we call it Nvidia as a drive net, or which is simply object detection network. You roughly need somewhere around 25 to 30 million images, right, to get to the level of accepted performance as well as accuracy which you can deploy in the self-driving cars. Of course, not everyone has that much data available, so people start roughly 4 to 6 million of the images to get a acceptable level of the performance, and they keep on increasing their coverage so that they can get the better accuracy. How long the training time takes, I think that's a good question. So we benchmark in terms of, because again every network is different, So your amount of the time the network will take will depend on, what's the resolution of your data is, how many epochs you are running, and there are many other factors. So we have taken on an average, for example, Nvidia is today developing more than 20 or more networks. And what we have tried to do is we have taken the average of those networks over a period of time. And what conclusively we came up that a single DGX1, which is an 8-way GPU server, can train 300,000 images, which is roughly 120 epochs in 24 hours. So one deep neural network you can run on a 1 DGX with a 300,000 data, and you can train in 24 hours. So now you can go and extrapolate. If, let's say, somebody is having a 20 networks, so you need like how much compute you need, and what's the amount of the labeled images you will need. Okay, so I will take a pause, and I hope I answered your question, Jordan. But if you have more questions.
Oh.
Okay, perfect. Gerard, do we have the next questions for Manish?
Yeah, so the next question is, what are possible simulation development kits for AV software development?
Yeah, that's best answered by Matt Cragen, to be precise. If Pradeep, can you, do you have some insights?
Sorry, I was just trying to. Sure. What was the question again?
Okay, I'll repeat it. What are possible simulation development kits for AV software development?
Okay, so from NVIDIA's perspective, I think we have this platform called Drive Constellation platform. So Drive Constellation platform, which is, you think of it's a 2-way server. Okay. There's a lot of background noise, and that's fine. I can understand people are working from home. Okay, so in the Drive Constellation server, which is consisting of the 2 servers, and one is what we call as a Drive Constellation simulation, and second what we call as a Drive Constellation computer. Okay, and we also have something called Drive Sim software. So you think of how you go and simulate, any of the sensor models, or how you go and integrate any of the vector dynamics models, or like traffic modeling. Everything you can do through this layer of the software, what we call as a Drive Sim, and all together we call as a Constellation platform. So this is what something, what NVIDIA is, offering to our customers, as well as, to our partners. You can find more details on that if you just go and, search on NVIDIA website about Drive Constellation. There's a lot more details available, but I think that should be a very good starting point for you.
Yeah, Pradeep, thank you very much. That was, I believe that was helpful. Meanwhile, I'm actually pulling up the reference links for the requesters. They can go and read more.
Yeah, I'm trying to go through these right now. All right, there's another question in here. It's a general question about Drive. The question is, we do research on human-related interactions with AV. If I were to implement Drive on our own autonomous car, how easily can I get the system to do something out for the normal drive down the road functionality? You want to take that one, Pradeep?
Do we have Luke on the call? Or? I think this is a good question for him. But
yeah, Luke is in the break room. I think I would advise to moderators, if you can line him up for Luke. We can put in the queue for Luke.
Yeah,
I'm having a difficulty in looking the question, so I'm trying to.
Here's another question. This question is, we have an on-premise GPU node with 8 RTX 8000 GPUs connected pairwise using NVLink. This person wants to know the options for job management tools for multiple users for this setup. Currently, we plan to use Airflow on top of Kubernetes.
Okay, so probably the best way to start is look at NVIDIA's DevOps software stack, which is open source, available on the GitHub, which will provide you a Kubernetes-based orchestration system, as well as it will also have the monitoring as well as the logging capabilities. So Manish, maybe if you want to show that's available on the GitHub as a web page, and people can just go and download it and start using it.
Yes, I will send the link shortly. Yeah. One question as well, Pradeep, interesting. I mean, although we have recommended Matt Damon to be in queue with Matt Cragen, but the question is, did you ever use synthetic data in your training, and what was the usage percentage?
Okay. Yeah, sure. Let me answer that. So, as of today, most of our work has been done on the real data, because NVIDIA today has, a fleet of the cars which are running, and we are doing the data campaign. And we have millions of the images which we have collected and labeled, and we are training the data on the real, on the real actual collected data. On the synthetic data, I think that's something is under, our very active research, and we are continuously evaluating that. And, for example, some of the in-car experience networks, for example, you might have heard of gaze detection, or like, the facial recognition, or maybe something like, the lip reading and all that, which you might need to get a better experience for the people in the car. Some of these networks we have tried out with the synthetic data, and results are good. But overall, we are still investigating how good the synthetic data can be, and where all we can, make it really useful.
Yeah, thank you, Matt. I hope this answers your question, but if not, keep asking again. Follow on the same thread. Folks on the line, I apologize for the intermits. We are just doing first in, last out kind of. If I missed your question, please copy it again. We'll bring it up. Earlier, I was busy talking on the slides, so missed a couple of them. There's one question which I wanted to bring up was, okay, Vish Rajalingam, but I think he's been put in the queue. That's good. The question is, NVIDIA Drive has a great set of startup features for an autonomy stack. Agreed. However, if a team is focused on developing own autonomy solution, would you still recommend NVIDIA Drive? If yes, can you elaborate on some distinct production-ready features? I believe Drive IX is a great start point for them. Pradeep, what do you think? I can point them to the entire stack of DriveWorks and all the modules we have built in there.
Sure. So, okay, so NVIDIA's Drive software stack, that has a multiple parts, right? The base layer, what we call as a Drive OS, and then we have what we call as a DriveWorks, or we call as, and then on the top of that we have a Drive AB, right? So DriveWorks is, you think of it's a collection of all the image and the signal processing libraries which you will need to develop the autonomous driving software stack. We also ensure to making a lot of our networks available as a part of our NGC, where you can go and download some of the latest networks which NVIDIA has developed, and you can use that. Again, they are not open source, but you can use them as a network, right? So they are available through NGC. So for any developer who is developing their own software stack, I will recommend them to start at the DriveWorks layer, which will be the best thing to take advantage of a lot of work, all the libraries which NVIDIA has already put up in place, as well as that will also gives you, a very fast route to the development. For example, DriveWorks has something called sensor abstraction layer, SAL. And if you are already dealing with a lot of sensors and you know how to go and get that data into your stack, I think that layer can help you. It has a lot of like ego motion, kind of the routines which are easily available. And then this is again built up on the top of CUDA and CUDA-X. So you can also have the flexibility to write any code directly in CUDA or using any of the CUDA-X libraries. For example, you can use any FFTs, you can use cuBLAS, you can use cuSparse, you can use cuDNN. There are multiple libraries available. So to summarize, I think DriveWorks is the best way to start if you're developing the stack. And you can still use a lot of software stack underneath it, which is CUDA and CUDA-X, TensorRT, everything.
Yeah. And to the question, the person asked a question, I have shared the link where you can go and read more. It will take you to the developer.nvidia.com to access the software. There will be terms and conditions, and you will be able to get your next steps. If you need more info, you have my email ID. Feel free to reach out. So moving forward, one more question before we move into conversations to all the attendees. Please use the sign up form and make a request. It's easier for us to, queue it up. Thank you. Yeah. Jared, you were saying something?
Yeah, I was going to say there's a good question out here. I think, have there been any known successes utilizing synthetic to real transfer learning? Do you balance any synthetic modeling for verification or validation of algorithms prior to pushing to real-world autonomous driving?
So this is, so this is very much like on the basis I just responded a couple of minutes back about the way we are using the synthetic data. Again, I will say, this is under very active research at NVIDIA. We are evaluating, but I don't believe that, anyone will, release any network just by training on the synthetic data. Because, ensuring that this really works on the real world data, people will mix up both the things. And, but in what ratio, and when they will, what will be that good inflection point where people will start moving from the synthetic data to the real world data or vice versa. I think that's something is still under active research.
Yeah. And to Jared, actually, all the questions are good, right? You said it's a good question. Is there any bad question ever?
No, they've been pretty good. I'm trying to figure out. There was a follow on that. Trying to find it here. Sorry.
There's a question, I think, while you are doing Jared, there's a question on Constellation. I'm just going to, can we run the Drive Constellation computer on premise while having Drive Constellation simulator in the cloud? I can feel this one. I've shared the link from where you can make a request. This is work in progress. And answer is yes, soon you will be able to do this. Pradeep, you want to add something to it?
Okay, so you already responded, Manish, but I think as of today, the answer is no, but going forward, we are trying to enable these capabilities. Yeah,
exactly. But there is a form, Gaurav, this question you asked, there is a form, there's a link to the developer site. There's a contact us form. If you fill that in, whenever we are ready with it, you will be reached out and you will have the early access. So Pradeep, this is, I think, because you work across industries, this is a good question from Will. Are any of the drive tools possibly useful for agriculture object detection or in different area like medical imaging, etc.?
Yeah, so that's a very good question. And, to be honest, I think most of the, there are two parts here, like which every one of us has to understand. One is the entire infrastructure and the DevOps software which you need to basically run that infrastructure to go and train your models. I think that pretty much is a standard, and you can leverage across the work which you have done in, let's say, autonomous driving across any industry. Because, for example, in healthcare, when you're developing the segmentation models, right? Or for example, when you're trying to detect, for example, this COVID-19 right now, so much work going on in terms of how to use AI to detect some of the patients with the COVID-19, issues. So, all of this requires the similar kind of the infrastructure. So any work which you have done here, you can very well leverage, that work into any other industry. So this is on the infrastructure side. The second part is, which is basically on the, some of the best practices, of the entire deep learning workflow. So you think of the every deep learning workflow is very much same, whether you train a healthcare network or you train a network for, detecting the faces in the video analytics, or you do it for, finding the objects, when the car is driving, or a robot, who's trying to navigate. So, the workflow starts always with, okay, you need to go and collect the data. You need to go and clean the data. You need to label the data, start training, and then you deploy that network and see how it is working, validate that, and that loop comes back, right? Because you find out that there are corner cases, you collect more data, and you keep on refining your network. So this entire workflow is used across all the industries. The third part, which is, hey, can I use my exact network architecture to train the models? Let's say I'm doing some objects being detected in, when I'm driving my car, and can I use to detect, something else when I'm when I'm doing some other industries? This is not that straightforward, but you can always use the same algorithms, but your data set has to be very different, right? And that's where you start learning, you start retraining your networks with this neo data set to really make them detecting the objects which you are looking for, or any other thing which you are doing. There can be some sort of a leverage here, but it's not, this will require, more work as compared to the previous two options which I mentioned.
Yeah, thank you, Pradeep. Yep, I think that kind of answers it, in my opinion. Will you have more to it? Please continue on the thread.
It's a question here. How many frames per second would be considered as enough for inference in autonomous driving?
Okay, that's a good question. And, generally, most of the cameras are running at 30 frames per second. And, it depends, there are a couple of factors, right? For example, at what speed you are driving your car, right? So, for example, number of the frames per second which you need to process will differ when you're driving a car as 30 miles per hour versus 100 miles per hour. Okay, so of course, you would like to process each and every frame, so that you can get the right decision. But, you always has the limitation of the computation which is available inside your car. So that's why you may not be. So, the key factor here is to really understand at what speed you are saying that you're driving the car and it will be safe. Okay, so that's the key part. I don't have exact number, because the numbers will depend on a lot of factors, like, what kind of the cameras, what the speed you're driving, what's your safety criteria. So there's not any fixed number, but I hope you got the understanding that why this has to be computed at different scale, because your input to this problem will define your output.
Okay, next question here is there any open source simulation software from Nvidia or other place for a fixed camera monitoring traffic in city or highway with prepared labels, different conditions in weather, congestion, etc.?
Okay, from Nvidia, we don't have, as of today, any open source software. available for the simulation. I think DriveSim, the software which I was talking about, that's not open source today, and I don't think so that will be we will be making available that as open source. Again, there is a difference between making something available for free to use versus open source. So again, we haven't even decided whether we will make it available for everyone, but as of today, but definitely it's not open source. About the community, I think I will really recommend you to look at there's a lot of communities. Even if you do the Google search, you will find a lot of options, and I will recommend you to go and look more there rather than I suggest that.
Yeah, Jared, you want to move to another one while you are doing this? Yeah.
All right, here's a question. How many detection classes do you have on an autonomous vehicle? And can you detect the road cracks also?
Okay, so, we are continuously working in terms of how many classes we are adding. I don't remember off my head, but it should be, I think we have more than, I think 5 or 6 classes which we are doing today. The road cracks is something which, which we I think as of today we don't have that. But you think of if the cracks are much bigger, we have something called what we call as a more like a free space segmentation, and that may figure out some of these holes and figure out whether this is safe to drive in that places or not.
Yeah. Between the conversations, again, a quick reminder to everyone, all the attendees, please fill up the form. It's easier for us to field the questions, point you to the right expert. There are break rooms. We have the product managers and solution architects waiting for you. So if you fill the form, it's easier for us. Thank you. Jared, any what's next? I'm actually trying to clean up, make sure that everyone is getting on the mark. Yeah.
There's one. Here's one. What are the most recommended backbones for autonomous driving? What regional proposal network is recommended? So, like FRCNN, YOLO, SSD.
I'm not the right expert to just I think we should respond back to you in more detail later on. Every network generally has a different kind of the requirements, and most of the networks which Nvidia is developing today is not what any of the the standard networks which you talked about in your question. Of course, a lot of people, for example, if you're working on object detection, you start with YOLO or you start with like, ResNet 50 kind of the networks. Even at long time back, we started working with some of these networks, but over a period of time, we have far more deviated from what we started. And, the reasons were, to get the accuracy which we need to really meet the demands of what we are trying to do, as well as third thing, to simplify the networks, to reduce the compute complexity so that we can run them faster in the car. So there are a lot of factors which will determine, what kind of the network architecture you can use to design a specific network. And we will be happy to get back to you with more details later on, on specific, the standard network types which we are using today.
Hey, Pradeep, before anyone forgets, thank you very much for sharing your knowledge. It comes in helpful. So more questions, Jared. While Luke is also coming in the common room, Luke and Matt. But meanwhile, there's a question on edge devices.
Oh, I see that.
Yeah.
Okay, so what edge devices are you using on autonomous vehicles, and do you send any process data to the cloud.
Okay, so edge devices, this is something very subjective just to understand, because everyone has a different way of understanding the edge devices. So maybe my follow-up question here to the person who has asked this, what do you mean by edge devices? Do you mean really a device which can be remotely managed in a cloud native way? If that's the question, then my answer will be different versus the edge device. You simply means, okay, you have a computer inside the car which is actually running all the algorithms to drive the car, as well as that computer is connected to the cloud so that it can later on, get the data which is learning while driving and send it back to the cloud. So as of today, just to finish, we already have a computer in car, and we have a way by which we can go and for example, like some of the map updates thing, right? So we need to go and upload back some data into the cloud, and which we can do that today. On the edge side, a edge device which is remotely managed, securely updated, and I think we already come up with what we call as the EGX, which is our EGX platform is our hardware and the software stack, which is a cloud native software stack which you can go deploy at edge and manage it to run the AI at edge. So that's also very well feasible. If you are asking the next question again, whether you can do this in car, probably yes. The answer is yes. Why not? But I think it depends what the customer's needs. So please reply back to the comment so that we exactly know what specific scenario you were looking for.
So a little businessy question here. I'll throw in, hoping Luke or Pradeep, if you can answer. The question is, with regard to the various hardware platforms, example, Drive AGX Xavier, Drive AGX Pegasus, and the minimum orders that Nvidia generally requires for moving to production, not half units for prototypes. Okay, so you want to answer, Luke? Go ahead then.
Sure. So what we are providing to the ecosystem is a development kit. So basically, what you can buy from Nvidia is our Drive AGX Xavier, Drive AGX Pegasus dev kit. So the minimum order for that would just be one. To move into a production type application, you would typically want to work with a tier one or other manufacturer to be able to create a production ready platform. But the dev kit is essentially what we're developing and providing and supporting. Pradeep, you had anything else to add to that? But hopefully that'll answer that one.
No, that's a good answer. And just to add, every business is different, right? So if you're working for a specific company and you have some requirements, I will always encourage you to contact your local salesperson, and the person will be very happy to guide you through all this business, the questions, how much, what's the minimum, because this is a very different question, cannot be answered in a black and white manner.
Yeah. So this conversation from enterprise going towards the embedded side, but the question is, another question from Mayok is there a better communication channel between Xavier A and Xavier B on an NVIDIA Drive Xavier? The current 10 GB Ethernet connection seems slow. Anyone?
So I could probably try to do that. Let me see if I can.
Or if you can point to some reference material, not to, and we can have a follow up, because this is more focused to enterprise side, training and simulation.
Yeah, so I would say to address that problem, there is an internal connection between the two Xavier systems. So you can basically, there's a couple different applications that you can use to connect the two of them. If you're seeing something that's generally slower than what you would expect it to be, I would encourage whoever's developing on the platform or the person that asked the question to go ahead and post a question on our NVIDIA Drive forums. So typically we're there to help troubleshoot those kinds of technical questions, to be able to dig in a little bit deeper, try to understand what expectations you should have for throughput between Xavier A and Xavier B, for instance. And we can help, I guess, dig in a little bit more detail to help address the question.
Okay.
We just have another question here. Not sure if we answered this, but I'm going to go ahead and ask it just to make sure. It says, it's asking, is DriveOS generic in nature for users to build custom AD solutions? In detail, number one, is DriveOS only specific to AGX systems, or can it work on a custom NVIDIA GPU rig? And can DriveOS be simply used as a substitute for ROS?
So I'll try to address that one. So in general, DriveOS is the operating system and a collection of various software libraries that help accelerate the underlying hardware architecture. So if you're developing, part of DriveOS is potentially the operating system. So if you're moving that from one platform to another, and non-NVIDIA platform, you're not able to basically take the operating system and put it on some other PC environment, for example. That being said, we do have quite a bit of flexibility on top of DriveOS. So, for example, you can compile and run ROS applications on top of DriveOS. We actually have a guide on in our documentation on essentially how to cross-compile ROS and run your ROS applications on top of DriveOS. So if you think of DriveOS as a generic operating system with a set of other libraries and other things that leverage the hardware underneath it, that kind of helps you understand where DriveOS sits with the whole software stack. And it is generic in that, basically you can take your software solution and run on top of DriveOS and use the tools that are available from there. So hopefully that covered that one.
Yeah, thank you. There's a question by Gaurav. I'll actually point into the breakout room, but the question is, what are the typical speedups seen using TensorRT version 7.0 on, say, vanilla faster RCNN network? So more one-on-one type of question, bringing it up here.
Yeah.
Michael,
do you want to proceed in one-on-one room?
Whatever. If you are here, I didn't know you were in this room. Go ahead, please, Michael.
Yeah, I think it's better than we have like a more detailed conversation on this.
Okay.
There's no straightforward answer. Yeah, there are details to it.
Yeah. And please share the reference link so that the Gaurav can read more about it. Yeah, thank you. So we'll move you to the breakout room. Iris.
Yes, will do.
Thank you.
Room 4 for me.
Okay. Jared, anything we have missed? Any specific question in this open chat room?
I don't see any that we've missed. I'm going through it right now.
Yeah, Anant, I see you in the common room. Welcome. Can you hear us?
I just joined the common room.
Great. I actually, why I'm asking you, you were in one-on-one rooms. Is any specific common question been asked to you by a couple of folks? If you would like to bring it up here and share with this wider audience.
Yeah, sure.
On the training side.
So, the questions that were brought up in my one-on-one room.
Mm-hmm.
Yeah. So
anything which we all can benefit.
So one of the questions was about validation. Basically, how do we actually come up with scenarios? How do we identify scenarios that need to be tested? What is the software that we're using and things like that. So it was from a person called Elham and based out of the UK. So we actually have the DriveSim software that is capable of doing all this. And do I need to go in through we can set up a one-on-one if you want me to take you through the software, or
No, we will compile all these questions, but anyways, we thought we'll have a minute. We wanted to. Thanks.
Yeah.
Yeah, Anand. I'll take a note from you and share it with this team.
And then the other question was basically about how synchronization happens during data ingestion. Basically, because we have a lot of sensors that are on board the car, so we wanted to know how that basically happens.
Okay, thank you. So for while we are at the tail end, I want to get more questions from the team, and we can have follow-up conversations. But quickly wanted to highlight the importance of NGC Software Hub. If people don't know, it's a Nvidia GPU cloud. It doesn't mean we have a cloud. It means it's a repository it's an artifactory for containers, datasets, frameworks optimized to function on GPUs. And our DGX system, and they're all optimized and tested on DGX especially. So this is one place you would want to definitely go and create a sign-up account. And you don't even need to create an account. You can download these containers from right here. I somehow cannot bring in the URL here, but this URL is up here, nvidia.com/GPU cloud. What we are constantly working on supporting the community. You will find all the application acceleration stacks in here for HPC, data analytics, deep learning, machine learning, hyperscale inference, rendering, visualization. Everything is built on top of CUDA. As we said, CUDA is our base frame platform. It's portable across all the different form factors of GPUs. So we would highly recommend you start building, utilizing our containers. You don't need to worry about anything on the lower side. We take care of all the acceleration and libraries functioning on every type of GPU made by NVIDIA. So moving from now towards the tail end, I want to leave some things for your reference here. These slides will be available on the website, but these are important URLs for a developer community. You can find everything what we have to offer on information, on the documentation, on these SDKs and tools, libraries, on developer.nvidia. For the containers I just mentioned, go to ngc.nvidia. We have a very engaged forums specific to each and every vertical and subject and SDKs on devtalk.nvidia.com. Just to emphasize again, we have 1.7 million developers in our community. So that's really rich and great place to get your help. Technical documentation is all docs.nvidia. Most of the developer.nvidia links will actually point you to docs. Deep Learning Institute, we have been doing this for many years. We have come a long way. This is courses. You can train yourself depending on where you are at a beginner level or intermediate level or even advanced. We have courses for each and every level of person. In blogs, dev blogs is a great, whenever we learn with our customers and we accelerate the applications, we actually cover them, even mention the code. You will get a lot of information on devblogs.nvidia. A lot of news, developer-focused news here, and webinars and GTC on-demand content, this one is one of that. So you will find it on gputechconference.com.
Hey, Manish, there was an ask that I don't know if you're done with the slides, but if you can put the first one back up with all our contact info, that was an ask by
definitely
one of the participants.
Yes. To visit up, we have shared all the email IDs, everyone, depending on the interest, you can reach out to us.
There was a question, it's a little bit involved, from CG, I think is the person. I think we're going to probably have you take that offline. I don't know if there's time to get into a breakout room with Luke, but that's something we can take that question and then probably have him answer that offline.
Yeah, I'm seeing this question. How involved is the process to convert from x86 64 C++ framework with NVIDIA GPU using Apollo Drive, CyberRT to running on Drive JXePeyKy? Yeah, I won't field it here. Same question, but for this is, if Luke, if you have some bandwidth, I don't see Luke in this room right now. But we'll have this question, CG. Yeah.
We have moved CG into the breakout room with Luke.
Okay, you already moved CG over there. Great. I would consider this an embedded question, so don't want to fill in enterprise side. Great. Anything else, Jared? We are missing last 4 minutes left.
There's one question I say that we haven't answered. Do you provide any help on porting HPC software from CPU to GPU?
When you say help, means you have to be specific. Means we give you a lot of tutorials and guidelines and best practices what to do. But again,
let me try to answer this question. So, NVIDIA actually, we actually really need our customers to own their entire software. And that's the reason we come and help you in terms of giving you the best practices and the tools which you need to port your applications to GPUs, right? And that's the first thing which we do, because we believe at the end of the day, it's you who will be owning this code and you will be maintaining this code. Even if, let's say, we once port the code, that will not be helpful for you because you have to keep on maintain it as long as you shall live. So, with this, I think there are a lot of tools which is available, a lot of online educational material, as well as, for example, these kind of the forums where we come and enable our developers to come up and discuss about their issues. And, that will help them in porting their, applications to the GPU computing. That's the best way with our experience, which is working very well with all the developers.
Yeah. Thank you, Pradeep. I believe that answers are in the same lines. But again, to wrap up, just 2 minutes left. We have shared all the email IDs. We have shared all this content will be live on the site. And if you have filled a form and we are not able to answer your question in this either break room or in the common room, we will reach out to you with relevant answers in coming days. So Iris, I see that one-on-one rooms are still going on. And between to log out of this session, there's no log out. You need to close the browser button and you will be out. Thank you very much, Pradeep. Special thanks to you, to all my friends here, Venkatesh, Siddha, Anand, Jared, Iris. Thank you very much for making this. I believe it was useful. We couldn't answer all the questions, but as much as we could. And through the forms, we have collected a lot of questions. We'll respond as appropriate. And thanks to Matt and Luke too.
Thank you to our experts and thank you to our attendees for your participation in this Connect with the Experts sections. We really appreciate your support and we hope this session was educational and informative to you. To simply exit this classroom, please feel free just close your browser. Thank you everyone again for your participation.